Today's question: an ideal gas is taken through a cycle A, B, C, A as shown in figure. If the net heat supplied to the gas is in the cycle is 5 joule, the work done by the gas in the process C to A is. So this is the figure given to us, and from the figure we can easily see that the points A and B are at the same pressure, which is given as 10 Newton per meter square, and point B and C are at the same volume, which is given as 2 meter cube, and point A is having a volume of 1 meter cube, and C is having a pressure which is lower than the, you can say, the pressure of point A and B, and which we can assume for the sake of convenience that let us suppose it is given as PC. So let us first of all interpret this entire process and try to solve it further. We can say that interpret the process now. The first part is the process from A to B. A to B, and this process is having a constant pressure, and this constant pressure is given as, let us suppose, taken as P rather, and the value of P, it is given as 10 Newton per meter square. Next is our process from B to C. From B to C, and this is a constant volume, and let us suppose that is given as V, taken as V rather, and this V is given as 2 meter cube. And the third process is from C to A. Third process is from C to A, and in this process the entire cycle returns back to A, starting from A. Okay. So you can say that the gas returns from pressure of PC, that is pressure at point C, to a pressure, let me write the volume also, pressure PC, volume is our 1 meter, volume is our 2 meter cube, volume is our 2 meter cube, to initial state, which is having a pressure of PA, that is given as 10 Newton per meter square, and a volume, let us suppose we denote at VA, which is our 1 meter cube. So this is the entire description of the process, and let us try to find out you can say the cycle information as the given in the question. So we start with our cycle information. And the cycle information, it is mentioned in the question that an ideal gas is taken through this entire cycle from A to B, B to C, and C to A. Okay? And the net heat supplied to the gas is in the cycle is 5 joule. Okay? So we can write that the net heat supplied to gas, which is denoted, let us suppose, as Q net, and that is given as 5 joules. And according to the first law of thermodynamics, we can say that the work done in the cycle is given by your heat supplied to the entire cycle. So we can, from here we can say that work done in a cycle according to first law of thermodynamics we can write that the heat supplied, that is our Q net, is equal to work done net. So from here we can say that our work done net will be equal to or also equal to 5 joules. Now we are going to find out the work done for the individual processes. Okay, we have 3 processes. First process is from A to B, second is B to C, and third one is from our C to A. So we say work done by individual process. So first is our work done by A to B, and this is our constant pressure. And under constant pressure, we can write a formula that work done from A to B under constant pressure will be equal to P into delta V, and this we can write as P volume at B minus volume at A. And this we can write pressure is given as 10, we have 2 minus 1, and this comes as 10 joules. Next is our work done by the BC process. Work done by B to C, and this is under constant volume. Constant volume. And under constant volume, the work done is equal to 0. So we can write work done from B to C will be equal to 0. And now we come to the third process, that the work done by C to A, which we are supposed to find out, and let us call that as work C to A, and we are going to find out this value. And in the cyclic process, total work done is equal to work done by the individual processes. So we can write from here that our W net is equal to work done from A to B plus work done from B to C plus work done from C to A. And W net is given as 10. So we can write this as 10 is equal to A to B is our 15 B to C is 0 and WC to A we are supposed to find out. So from here we can say that work done from C to A will be equal to 10 minus 15, which comes as minus 5 joules. So the options that are given to us, option number A is the correct option. So you can say option A is correct. Option A is correct. So this completes the question. Thank you.